Hello, everybody. We're going to continue our discussion of subtraction and addition of fractions. Today, we're actually going to be working on with subtraction with renaming. So we're on lesson 6.8. We're on page 283 of the fifth grade Go Math textbook. And our essential question you should be able to explain or answer at the end of this lesson is, how can you use renaming to find the difference of two mixed numbers? All right, so let's look at the unlock the problem. So to practice for a race, Kara is running 2.5 miles. When she reaches the end of her street, she knows that she has already run 1 and 5/6 miles. How many miles does Kara have left to run? All right, so underline the sentence that tells you what you need to find. How many miles does she have left to run? And what operation should we use to solve the problem? Well, the word have left, words have left, is a clue that we're going to be subtracting. All right, so one way is we can rename the first mixed number. So 2.5 minus 1 and 5/6. Now we can estimate to get a general idea what our answer is going to be. So we could have 2.5 minus, well, 1 and 5/6, that's 1 plus basically 1. 5/6 is really close to 1. So 1 plus 1 would be 2. So if we have 2.5 and we take away 2, that would leave us with just 1/2. All right, so when we're finished with our problem, and we find the difference, we should be about 1/2. All right, so 2. We need to find a common denominator first, and we're going to use the common denominator to write equivalent fractions with like denominators. Okay, we know we can't add or subtract fractions with unlike denominators, so we're going to go ahead and make equivalent fractions out of these. So in this case, they're saying, well, a common denominator for 6 and 2 is 12 if I multiply 6 times 2. All right, so 6 times 2 gives me 12. 2 times what is 12? 6, right? 6 times 1 is 6. So 2 and 6, 12 is the same as 2.5. And 1 and 5/6, if I multiply the 6 by 2, that gives me 12. And 5 times 2 gives me 10. All right, so now I go to look at this and I subtract, and I see that I have to take 10 from 6. Well, we can't do that, right? So what are we going to do? Well, that's where we have to rename the fraction, the mixed number. So let's look at this. 2 and 6/12. We're going to rename it as a mixed number with a fraction greater than 1. So 2 and 6/12. That's the same as 1 plus 1. That gives us 2 plus 6/12. So 1 plus 1 is 2 and 6/12. Now look at what we're going to do with one of the ones. We're going to take one of the ones and we're going to rename it as a fraction with the same numerator and denominator, 12/12. And the reason we're using 12ths is because the denominator is 12th. So 1 whole in this problem would be equal to 12/12. So now if we rename the 1 whole as 12/12, we can add that fraction to the other fraction we had. So 12 plus 6 is 18/12. So we can rename 2 and 6/12 as 1 and 18/12. So now we'll go back up here. Okay. And so in a sense, what we did was we borrowed or renamed one of the wholes as 12/12. And we added. Okay, so we borrowed one of the wholes for 12/12 of a fraction. We traded them, right? Now we can subtract. 18 take away 10 is 8. Place the denominator 12s. And 1 take away 1 is 0. Now we should notice that 8/12 has a common factor of 4, right? 4 times 2 is 8, and 4 times 3 is 12. So 8/12 simplified is 2/3. So she has just about a mile left to run. We said our estimate was 1/2, so we're in the right neighborhood. Why is it important to write equivalent fractions before renaming? Well, basically, we need to know if we need to rename. Okay, and we really don't know that until we find equivalent fractions. All right. So that was one way. You could rename just the first mixed number. I can also rename both mixed numbers as fractions greater than 1. So in other words, you remember how to turn this mixed number into what we would call an improper fraction, right? So we can take 2 and 1/2, we can multiply the denominator times the whole number and add the numerator. Or we can think of 2 and 1/2 as 2 halves plus 2 halves, right? So 2 is equal to 2 halves plus 2 halves, 1 plus 1, plus 1/2. So that would be 5 halves. Or I can 2 times 2 equals 4, plus the numerator equals 5/2. So either way, we can turn those mixed numbers into fractions greater than 1. So 2.5 is equivalent to 5 halves. 1 and 5/6. Basically, I can write the 1 as 6/6 plus the 5/6. And that's going to give me 11/6. Okay, I do need to pause here. I jumped ahead. I renamed the fractions as fractions greater than 1 before finding a common denominator. So I want to reverse. I want to back up, okay, before I rename them. And 2 and 1/2, they're saying that a common denominator between 2 and 6 is 6. So I would multiply 1/2 by thirds. An equivalent fraction would be 2 and 3/6. And 1 and 5/6 is already in common. Now, at this point, we notice that we can't take 5 from 3. So now we would rename both mixed numbers. So 2 and 3/6 I can write as 6/6 plus 6/6 plus 3/6, and that would give me 15/6. 1 and 5/6 I can write as the 1 would be 6/6 plus the 5/6, and that would give me 11/6. Now we can find the difference. We have common denominators. Okay, and 15/6 take away 11/6 is 4/6. But 2 is a common denominator to both. Is a common factor to both. 4 divided by 2 is 2, and 6 divided by 2 is 3. So we still wind up with 2/3. Okay. If I had continued it on this side, I still would have got the right answer. But I want to make sure I followed the steps as outlined in your curriculum. All right. So number 1. So let's estimate. So we have 4.5, and we're going to subtract 3 and 4/5. 4/5 is close to 1. 3 plus 1 is 4. So we'd expect our answer to be about 1/2. So 4.5 minus 3 and 4/5. So let's start by finding a common denominator. 5's prime, 2's prime. Let's just multiply them by the opposite denominator. So 4 and 1/2 would become 4 and 5/10, minus 3 and 4/5 would become 4 times 2, 5 times 2. Because if I multiply the fifths by halves, that would give me tenths. And 4 times 2 is 8. So we have 3 and 8/10. Now I get to this point and I see that 8 can't be taken from 5. So I want to go ahead and show renaming both mixed numbers again. So 4 and 5/10 can be written as 10/10 plus 10/10 plus 10/10 plus 10/10. 1 whole, 2 wholes, 3 wholes, 4 wholes, plus the 5/10. All right. So that's what we're thinking of that as. And so if we add them all together, we get 10, 20, 30, 40, 5/10, which makes sense. 10 times 4 is 40, plus 5 is 45 over 10. And 3 and 8/10, we can think of the 3 as 10/10 plus 10/10 plus 10/10 plus the 8/10. So each 10/10 is worth 1. 1, 2, 3, and 8/10. Add the numerators together, 10, 20, 30, 8/10. So we could have instead just gone 10 times 3, because we know that each whole number has 10 in their denominator. So 30 plus 8 more is 38/10. So we have 45/10 take away 38/10. That's going to leave me 7/10. Well, half of 10 is 5, so we are close to our estimate. Right now in this one, 9 and 1/6 would be, an estimate would be 9 take away 3. So we expect an answer close to 6. So 9 and 1/6 minus 2 and 3/4. So let's find a common denominator. 4, 8, 12, 16, 20. And let's go to 6, 6, 12, 18, 24. I see that 12s are in common. So I'd multiply 1/6 by 2. 2 halves. And so I can rewrite 9 and 1/6 as 9 and 2/12. And 2 and 3/4 I can multiply by 3/3. And I would get 2 and 9/12. Well, I look here and I can't take 9 from 2. So I can rename the first mixed number. So I can take one of the whole numbers from the 9. In this case, I would trade one of the whole numbers for 12/12 plus the 2/12. So we have 8 plus 12/12 plus 2/12 equals 8 and 14/12. Basically, all we did was add 12 to the 2 to rename it. Minus 2 and 9/12. 14 take away 9 is 5. So 5/12, and 8 take away 2 is 6. So basically I have 6.5 as my answer. My estimate was 6. We're close. We're reasonable. And number 3. Estimate 3 2/3. Well, that's close to 4, isn't it? Okay, 3 plus 1 is 4. Subtract 1 and 11/12. So 11/12, that's close to 1. 1 plus 1 is 2. So we basically have 4 take away 2. So our estimate is going to be about 2. So we have 3 2/3. We have to take 1 and 11/12. Now I know 3 times 4 is 12. So I'm going to go ahead and go 3 2/3 times 4/4 would give me 3 8/12. I'm not going to do anything to the 1 and 11/12 since its fraction is already, its denominator is already 12s. Well, when I look at here, again, I can't take 11 from 8. So we got two choices. We can rename both mixed numbers as fractions greater than 1, or I can rename just the first one. I'm kind of partial to just renaming the first one. So here I would take 1 whole away from the 3. I would give 12/12 to the 8/12. 12/12 is equal to 1 whole. Okay, so that's the 1 whole is not disappearing. I'm just trading it for 12/12. So I'm going to rewrite that as 2 20/12 minus 1 11/12. Well, 20 take away 11 is 9/12, and 2 take away 1 is 1. I know that 3 is a common factor to both 9 and 12. So 3/4. So my answer is 1 3/4, which is close to 2. All right, number 4. 4 1/4 minus 2 1/3. 4 1/4 is close to 4, and 2 1/3 is close to 2. So I would expect my answer to be about 2. Now 3 is prime, so I can just multiply the 1/4 by 3/3, and I can multiply the 1/3 by 4/4. So equivalent fractions would be 4 3/12 and 2 4/12. But I can't take 4 from 3. So I'm going to rename by taking one of the whole from the 4 and trading it for 12/12. Again, the denominator is 12, so 1 whole would be 12/12. So I'm left with 3 15/12 minus 2 4/12. 15 take away 4 is 11/12, and 3 take away 2 is 1. So 1 11/12 is very close to our estimate of 2. So that's a reasonable answer. Number 5. 5 2/5. Well, that's close to 5.5. And 1.5, I'll just use 1.5. So 5.5 take away 1.5 leaves me 4. All right, 5 2/5 minus 1 1/2. Well, let's just multiply the denominators to each other. So 5 times 2 equals 5 4/10. And 1 1/2, we're going to multiply by fifths, which is going to give us 1 5/10. Can't take 5/10 from 4/10. So we're going to rename 4 4/10 plus 10/10 minus 1 and 5 tenths. So we have 4 and 14 tenths minus 1 and 5 tenths. It's going to leave us 3 and 9 tenths. 3 and 9 tenths is close to our estimate 4. All right, get a piece of scratch paper to do for 6 through 13. And let's continue. 11 and 1/9 minus 3 and 2/3. All right, you should recognize that 3 can become 9 because 3 times 3 is 9. So let's just go ahead and multiply 2/3 right now by 3 over 3. So I'm going to rewrite 11 and 1/9 minus 3 and 6/9. All right, well, we can't take 6/9 from 1/9, but we can trade one of the whole numbers for 9/9. 9/9 plus 1/9 is 10/9. So 10 and 10/9 minus 3 and 6/9. 10 take away 6 is 4/9, and 10 take away 3 is 7. So 7 and 4/9. That's about 7.5. This was 11. 11 and 1/9 is 11. 3 and 2/3 is 4. So we have about 7. So we're in the right neighborhood. Number 7. 6 minus 3.5. Now, technically, we can add up, right? We can say, okay, we're at 3.5. How much do I have to add to get to 6? But I want to go ahead and show you what we would do with this type of problem. So right now we have no fraction part, right? So I can't take technically a half from nothing. So I can take one whole from from the 6, right? Now, what fraction do I use? Well, I use the number I'm taking away as a fraction. So what would a fraction be that would be equal to 1 using halves? It would be 2 halves. 2 halves is equal to 1. 1 plus 5 is 6. So all I did was rename one of the ones as a 5 and 2 halves. Now I can subtract. 2 take away 1 is 1 half. And 5 take away 3 is 2. So 2.5. And 6 take away 4, or 6 take away 3.5 is 2.5. All right, number 8. 4 and 3/8 minus 3 and 1/2. So if I look at this, 2 is prime. Can 2 become 8? Sure it can. 2, 4, 6, 8. All I have to do is multiply by 4/4, right? So 3 and 4/8 taken from 4 and 3/8. Well, we can't take 4/8 from 3/8, but we can rename one of the wholes as 8/8. Okay, so we're taking one of the ones from the 4 and trading it for 8/8 because 8/8 is equal to 1. All right, so now we're just going to subtract 11 and 4. That leaves us 7/8. And 3 take away 3 is 0. So our answer is 7/8. Number 9. 9 and 1/6 minus 3 and 5/8. Okay, I'm going to make a list. 6, 12, 18, 24, 30, 36, 42, 48, 8, 16, 24, 32, 40, 48, 56, 64. I want to choose the least common multiple, so 24. So I'm going to multiply 1/6 by 4/4, and that's going to give me 9 and 4/24. And 3/8, 5/8 I'm going to multiply by 3/3, and that's going to give me 3 and 15/24. Well, I can't take 15/24 from 4/24. So I'm going to rename one of the wholes. And I'm going to replace it as a fraction of 24/24. Okay, so basically, why do we rename the first mixed number? It's so that the fraction is large enough to subtract the other fraction. So 28 take away 15 is 13/24, and 8 take away 3 is 5. So number 9, 5 and 13/24. And if we were estimating, 9 take away 4 is 5. So it's reasonable. Number 10, 1 take away a half. Our answer should be about a half. So number 10, 1 and 1/5 minus 1/2. 2's prime, 5's prime, just multiply them together. All right, well, I can't take 5/10 from 2/10. So I'm going to rename the one whole as 10/10. So we have 12/10 minus 5/10. 10 plus 2 is 12 over 10. And we already had 5/10. So 12/10 take away 5/10 leaves us 7/10. And we said our answer would be about a half, which it is. 11. If I was just estimating 13 take away 4, I would expect my answer to be about 9 as an estimate. Okay, so my estimate's about 9. All right, 5 is prime, so why don't we just go ahead and multiply the 1/6 by 5/5 and multiply the 4/5 by 6/6. Okay, we have common denominators, but you can't take 24/30 from 5/30. So let's just rename the 13 wholes as 12 wholes, and we're going to add 30/30 to the 5/30. Remember, the 30/30 is why we took one whole away from 13. Okay, this is still equivalent. 12 plus 30/30, which is 1. 12 plus 1 is 13, and 5/30. So I didn't make it smaller. All I did was trade one of the wholes for a fraction value. So 12 and 35/30 minus 3 and 24/30. 35 take away 24 is 11/30, and 12 take away 3 is 9. So 9 and 11/30. And we said our estimate should be about 9. So we're in the right area. Number 12, I would consider that to be like 12.5 minus 6. So I guess my estimate would be about 6.5 for number 12. So let's try it. 12 and 2/5 minus 5 and 3/4. Since 5 is prime, I'm just going to multiply it with the 4 to find a common denominator. So 12 and 8/20 minus, I'm going to multiply the 3/4 by the other denominator, 5. That's going to be 5 and 15/20. Again, we notice that we can't take 15 from 8, so we're going to rename the 12 holes as 11 holes and trade one of the ones for 20/20. Okay, so all we did was take one of the holes and instead write it as 20/20. In other words, renamed it. We added that with the 8/20. Now we have 28/20, which means I can subtract 15/20. That's going to leave me 13. 8 take away 5 is 3. 2 take away 1 is 1. So 13/20. But I also have a whole number component. So 11 take away 5, 6. 6 and 13/20. Half of 20 is 10. So this is slightly bigger than 6.5. And 13. 7 and 3/8, I would call that 7.5. And 2 and 7/9, I would call that 3. So we'd look at about 4 and 1/2 as our answer. So 9 and 8. Well, let's just go ahead and multiply them by the opposite denominators. So I'm going to multiply the 3/8 by 9/9. I'm going to multiply the 7/9 by 8/8. Okay, all I'm doing is multiplying the denominators to get a common denominator. 7 and 27/72 equals 2 and 56/72. I can't take 56 from 27. So let's rename the 7 holes as 6 plus 72/72. So if I add the additional 72/72, I get 99/72 minus the 2 and 56/72. All right, so just subtract. 9 take away 6 is 3. 9 take away 5 is 4. 43/72. And 6 take away 2 is 4. So 4 and 43/72. Half of 72 is 36. So we're slightly bigger than 4.5. All right, 14. 3 commercials are played in a row between songs on the radio. 3 commercials fill exactly 3 minutes of time. If the first commercial uses 1 1/6 minutes and the second uses 3/5 minute, how long is the third commercial? Well, basically, mathematically, we'd be looking at this. 3 minus the sum of 1 1/6 plus 3/5. In other words, 3 minutes, take away the number of minutes in both the other commercials. All right, so let's solve this part. So 1 1/6 plus 3/5. Well, let's multiply the 1/6 by 5/5. That's going to leave us 1 5/30 plus multiply the 3/5 by 6/6 because we're multiplying by the opposite denominator to get a common denominator. That's going to leave me 18/30. All right, let's add those together. 18 plus 5 is 23/30, and 1 plus nothing is 1. So basically now we have 3 minus 1 and 23/30. I'm going to rename the 3 holes as 2 holes and 30/30ths. The reason I'm using 30/30ths is because the other number's denominator is 30. So since I don't have a fraction here, I'm just going to write it as 2 and 30/30ths. And 30/30ths take away 23 is 7/30ths, and 2 take away 1 is 1. So 1 and 7/30ths minutes long. And 15. 4 students made videos for an art project. The table below shows the length of each video. Match each pair of videos with the correct difference between their times. All right, so we have to compare video 1 and video 3. Video 1 is 4 and 3/4 hours. Video 3 is 2 and 5/6. All right, so we need to find the difference between those. Well, 4 and 6. 4, 8, 12, 16, 20, 24, 6. 6, 12, 18, 24. Well, I could use 24, but I'm going to use the least common and make them 12s. So I'm going to multiply 3/4 by 3/3. So the equivalent fraction is 4 and 9/12 minus, I'm going to multiply the sixths by 2s. That's going to give me 2 and 10/12. Well, cannot take 10/12 from 9/12. So let's rename the 4 as 3 plus 12/12. That's going to give me 3 and 21/12, because 9 plus 12 is 21, minus 2 and 10/12. Subtract that, we get 11/12, and 3 take away 2 is 1. 1 and 11/12. So the difference between video 1 and video 3 is 1 and 11/12 hours. Now let's look at videos 2 and 3. Video 2, 4 and 2/5. And we're going to subtract video 3, 2 and 5/6. Okay, let's multiply by the opposite denominators. And 5 times 6/6, 2/5 times 6/6, and 5/6 times 5/5. So equivalent mixed numbers are 4 and 12/30ths minus 2 and 25/30ths. Can't take 25/30ths from 12/30ths. So let's rename the whole number as 3 plus 30/30ths. So 4 and 12/30ths can be written as 3 and 42/30ths minus 2 and 25/30ths. So 42 take away 25. Now I can't take 5 from 2, so I'm going to regroup. 12 take away 5 is 7, and 3 take away 2 is 1. So 17/30ths, 3 take away 2 is 1. 1 and 17/30ths. All right, and there is a 1 and 17/30ths. I think right there. And videos 2 and 4. I am going to assume that it's 1 and 9/10, but I want to make sure by solving it. So video 2, again, is 4 and 2/5 minus video 4, 2 and a half. All right, I'm just going to multiply the denominators by their opposite denominator. So 4 and 4/10 equals 2 and 5/10. Can't take 5/10 from 4/10, so rename the 4 as 3 plus 10/10 to get 3 and 14/10 minus 2 and 5/10. So we get 1 and 9/10. So yes. All right, page 286. Connect to reading. An amusement park in Sandusky, Ohio offers 17 amazing roller coasters for visitors to ride. One of the roller coasters runs at 60 miles per hour and has 3,900 feet of twisting track. This coaster also has 3 trains with 8 rows per train. Riders stand in rows of 4 for a total of 32 riders per train. The operators of the coaster recorded the number of riders on each train during a run. On the first train, the operators reported that 7 1/4 rows were filled. On the second train, all 8 rows were filled. And on the third train, 5.5 rows were filled. How many more rows were filled on the first train than on the third train? Well, let's see. We have 7 1/4 rows filled. Second train, all 4. And the third train, 5.5. So when you summarize, you restate the most important information in a shortened form to more easily understand what you have read. Okay. Identify and summarize the important information given in the problem. Okay, so we know that there are 3 trains. With 8 rows each. Right, we got that from right up here. 3 trains, 8 rows per train. They also told us riders stand in rows of 4. So 8 rows of 4, I can have 32 riders per train. All right, what else is important? Well, we know that the first train was 7 1/4 filled. The second train all 8 rows were filled, and in the third train, 5.5 rows were filled. Use the summary to solve the problem. Well, we have to find out how many more, that means subtract, how many more were on the first train than on the third train. So 7 1/4 minus 5 1/2. Well, we should easily see that 2 times 2 is 4. So let's use 7 1/4 as our common denominator, fourths as our common denominator. So 5.5 times 2 halves would give us an equivalent fraction of 5 2/4. Well, I can't take 2/4 from 1/4. So let's rename the whole, one of the wholes, as 4/4. So we now have 6 5/4 minus 5 2/4. Okay, I didn't leave myself enough space there, so I just wrote it down here. All I did was added the 4/4 to the 1/4 to get 5/4. So 6 5/4 minus 5 2/4. 5/4 minus 2/4 is 3/4, and 6 take away 5 is 1. So 1 3/4 more rows were filled. And 15. How many rows were empty on the first train? How many additional riders would it take to fill the empty rows? Well, if there's 8 rows and the first train had 7 1/4, How many writers would it take to fill the empty rows? So let's answer the first question. 8 take away 7 and a fourth. Well, right now we don't have a common denominator. So let's rename one of the wholes as 7 plus 4 fourths. Subtract, we're left with 3 fourths. So 3 fourths rows were empty. How many additional writers would it take to fill the empty rows? There are 4 writers per row. So 3 fourths empty means you need 3 more writers. Okay. All right, so that's it for lesson 6.8. In our next lesson, we're going to be working on patterns with fractions. So until then, I will see you soon.